Hello, everyone. Okay, I'm very excited to tell you about the Polkadot Unity SDK. My name is Rostislav. I'm a student at Gymnasium Jaroslava Hejrovského. I also studied at Polkadot Blockchain Academy. I also finished summer school of Solana, so I have got also some knowledge across multiple blockchain ecosystems. And okay, so let's move on the presentation. So this presentation will be split into 3 parts. The first one will be on how to use the Polkadot Unity SDK. I will show you what it is capable of. I will show you some examples. Then in the second part, I will show you the demo game for the Unity SDK, which is called Hexalem. And I will also show you how it works and how you can make your own fully on-chain game. And if there is enough time, I will also show you Hexalem live demo here. Okay, so the first part is strictly aimed at developers, so all of you others have been warned, so you cannot complain. So I will begin with explaining what Unity is. Unity is a very popular game engine. It's used very by indie developers, and so it's very important, and we have created this Polkadot Unity SDK, which is now released as a verified Unity asset store solution. So many game developers can find it, and it's a good exposure to the ecosystem. And it consists of multiple parts, and I will start with the first part, which is called sub0 API. It's the base of this Unity SDK. It can be easily compared to, for example, Polkadot.js API. So what it does, it's that it implements all of the sub0 primary types, and along with their respective scale encoding and decoding, which is very useful. So as you can see, you can have some like numbers or account IDs, so like all of the primary types. Then we also implemented the RPC client, which allows you to connect to the blockchain node. And we also made a brilliant abstraction for you to get some properties of the chain, like metadata and like others. And you can also query storage. This example shows you how to query your balance. And also, you can sign and submit transactions. This is for a balance transfer, but you can do many more things. And then we've made this really powerful tool, which is called sub0.net toolchain. You download it just by this simple command, and you don't need to worry about it. You can find it in the documentation, and you can just copy and paste it. And then you will also copy this line of code. You will have to fill in your details, like your WebSocket URL. But when you do it, it will and run it, it will generate a bunch of code, which will look like this. And it will create a C# representation of the whole chain. So you will have all of your balances that are present on that chain. It will also generate a C# representation for all of the sub0 types that are present on that chain, even the custom ones. And it will also implement their scale encoding and decoding, which actually saves a lot of time. I know that you can maybe do it for 1 or 2 types, but if you are building a big game with like dozens of types, then it saves your time massively. And also, you cannot make a typo, because this will always be right. So it will always work. And actually, everything that I've explained right now, you don't need to run the generation code for most of the chains, because we have already pre-generated it for you. So it can save you a lot of time. OK, and I tried to challenge myself. I've tried to query my balance. I did it twice, once with the sub0 net toolchain code generation, and for the second time without it. And on a first glance, you can easily notice that with the sub0 net toolchain, it's not only cleaner and simpler, but the code is also much, much safer. So on the right, you can see that I had to find out what exact hashing functions I had to use. I also had to fill in some strings. Maybe I could have made a typo. And also, what if your chain upgrades? Then you would have to rewrite the whole code. But with sub0 toolchain, you can just run the simple command. It will regenerate all of those files. It will do all of those changes that are present on that chain. And your client code will still work as intended. Then we also made sub0 wallet. It's very simple. It allows you to generate new mnemonic phrases. You can also fill in your existing mnemonic phrases and create an account from it. And you can also export these accounts. So you can export them into a JSON file, which can be then imported into some other external wallets, like Polkadot.js extension. And you can also do it the other way around. And why is this important? It allows the developers to have a better user experience in the games. You can implement auto-signing, and also you can automatically create a new account for new users, so they don't need to worry about getting a new wallet. So it allows for a better onboarding. Okay, and I also focused a lot on the documentation, so I wrote one, and you can also find it in the respective GitHub repo and also in the Unity SDK if you search for it. So I think that's useful. And then I also made a few more tools. These are not part of the Unity SDK, but they use it and they expand it in even further. So I think you might find them very useful. The first one is plutonication. It's like Wallet Connect. It allows you to very simply connect any external wallets to your dApps, and it even works across multiple devices. So you might have a wallet on your phone and then a dApp on some foreign device, like Nintendo Switch, for example, or some gaming console. And you can very easily add it. It's very tightly added to the sub0 net API, so it easily works there. When you add it to your code, you don't have to change it anymore because it works with the existing codes. And then I've also made uniquequery.net. You might like this package if you want to build an NFT game. So what it does is that it allows you to query and index NFT data very simply. It allows many different NFT standards, and you can just do it with a single line of code like this. So if you just type this, it will find all of the NFTs that are owned by that address. And I've actually won a hackathon with this project. I won a second prize. And speaking of that Polkadot Global Series hackathon, I will be also a mentor at this year's Polkadot Global Series. So I strongly encourage you to go out and build an on-chain game with Polkadot Unity SDK, and maybe you will win some prize. I've actually done it this December. I went to Hong Kong, and we've made the demo game called Hexalem, and I presented there, and I've actually won the first prize there. So now it's your turn to win your first prize. Okay, and now I will tell you more about the Hexalem game. So this is the second part. So firstly, what it is. It's a fully on-chain multiplayer strategy game that's available for mobiles. You play it by placing tiles. Then you earn some resources, which allows you to place even more tiles. And then you breed more humans. And finally, you defeat your opponents. And it is a lot of fun. So you need to try it out. And it works like this. So typically, if you were building a Unity game, you would have the Unity UI. Then you would have the C# client engine with the logic of the game. And if you are building a multiplayer game, you would also have some sort of a project in the middle with the integration to the centralized backend server to handle the multiplayer logic. But because we are building a fully on-chain game, our backend is actually the sub0 blockchain. So we made our own node, which can be deployed to, for example, Polkadot or Tansi or any other service. And then we generated the code with sub0 net toolchain to get the C# representation of our chain. And when we connected it all together, it formed the Hexalem game, which can be now played by players and can be released to Google Play and other platforms. Okay, we also tried to optimize the code. We made unit tests for it. And we also made Hexalem in a way that it is hack-proof. So hopefully there are no exploits. And we also focused a lot on the user experience. So you don't need to download any wallets to play the game. You also don't need to confirm any transactions in the game because the game can auto-sign them automatically for you. And we also made a beautiful and easy to understand UI, which looks like this. As you can see, it's like very bright and colorful. It's very well described. Okay, and the vision of Hexalem is that we want it to be free to play. We will achieve it with free to play, with freemium tokens and also some redeem codes. We will definitely reward players for their social engagement. And the players will only have to pay for the ranked games. And by playing these ranked games, they would be able to earn some prizes, which will motivate them. And to achieve everything that I've said in the vision, we have made a few palettes, few custom palettes, which are actually reusable. So if you want to build your own multiplayer game, you might actually find a few of these palettes very useful. And I will explain them to you right now. And also these palettes are taking a full advantage of having a custom chain. You will learn soon how they work. Okay, so let's start with the ELO palette. ELO palette is the simplest palette that I will show you today. So what even ELO is? ELO is a rating system which can be found in many kinds of games, especially like the competitive multiplayer games. So like it can be found in chess or Go or maybe Counter-Strike or League of Legends. And ELO rating are some kinds of points that are showing the strength of a player at that given game. And this is the equation that tells you the resulting difference after the match. And this equation can be very easily added to your sub0 code like this. But actually, this is wrong because it's doing too many computations and match statements are much faster. So if we look at the formula again, we can notice that there is only one parameter, and that's b minus a. So we can actually pre-calculate the values for all of those parameters, and it will run much faster. Then I've made a matchmaking palette. So with the matchmaking palette, you would want to ensure these four things. So the equality, you want to play with an opponent with a very similar ELO, with a very similar skill at the game. Then the code obviously needs to be very efficient, and you want the game to be found very quickly. You don't want to be waiting there for your opponent for like the whole day. You want to play it right now at this second. And then also you want to achieve uncertainty so that like no other opponents can predict their opponent. So, yeah. And also these three properties are forming a matchmaking trilemma. So if you want to, for example, improve the equality a lot, then you would have to wait a long time for the exactly strong player as you need. So that's like not good. If you want to make it quicker, then you would need to, for example, check every second to find a match at like exactly 1 second. And if you want to save some computations, then maybe you will not check all of the players and you will not compare all of them together, which would like save it, but then you wouldn't be able to find exactly the strength of that opponent that you need. And this is the solution that we went with. We chose brackets for finding your opponent. So we realized that you don't exactly need 100% equally strong opponent as you are. So, but you are okay with a span. So the brackets would look like this. And we can easily agree that if you are here, you definitely do not want to play with some professional players at 2000 rating. And you also do not want to play with noobs at 0 rating. Then, to make the matchmaking quicker, we made these 2 improvements. So if a lot of players join at the same time, then we will initiate the matchmaking right away because we have got a lot of players to pair. So that's really good. But this is a very ideal scenario. In the most cases, it will look like this. So maybe you will wait 3 blocks and only 2 players will join. Then you wait more, only 1 joins. Then a bit more blocks, only maybe 3 more players join. But it's still not enough. Maybe you would want to wait a bit longer. But then at every 10th block, which means at every minute, we will just decide to matchmake them no matter what, so that the players don't wait for too long. Okay, and then to improve the efficiency, we chose a brilliant data structure. So instead of saving them in a list, we chose a ring buffer. It works like this. Players join at the top and they leave from the bottom. The only drawback is that they cannot leave from the middle, but it doesn't matter that much, actually. And then to achieve the uncertainty, you just need 2 of these things. You just need a lot of players, because if you pair only 2 players together, there are no other variations to pair them differently. And you also need a good source of randomness. Then we made the affiliate palette. The goal of this palette is to expand the community. We do it by assigning a status to every account and also the number of affiliates that this account has. And this is the example of it. So like on your chain, you can set the affiliate max level constant for that palette. And then, for example, if it's set to 2, and I was invited by the player 3, then my affiliates would be player 2 and player 3. And you can find this info very easily on chain, so it's useful for onboarding. And then, lastly, we made a free-to-play palette. Sorry, we actually didn't make it yet, but we are in the makings of it. So we have got a strong idea on how to do it. The goal of this palette is to allow any players to play on chain for free, which is a very difficult task, especially if you want to mitigate bot spams, which you definitely want. So we've achieved it with the introduction of 2 tokens. The first one is called free-to-play token, and then the second one is free action token. These tokens have some interesting properties, like that they can be used only for playing the game, and also they are soul-bound, so they cannot be transferred to any other account. And why did we introduce the second token, the free action token? It's because we cannot predict how many transactions the players will spend on that game. So maybe if we think that the game will last for like 100 transactions, then we can give them maybe double of that amount, so 200 free action tokens. And this way they would be able to finish it and we can calculate it much better. And we are also focusing a lot on reducing any risks. So the palette works like this. An established player would invite a new player via the affiliate palette, and then this new player can ask for an airdrop of free-to-play tokens, and when that player has the tokens, they can start the new game, and they will pay with the free-to-play token. And in exchange for starting the game, they will get the free action tokens to play the game. And then they can play, and once the game finishes, we can remove all of their extra free action tokens that are left. Okay, so this is how it looks. And now it's time for a Hexalem demo. Can you please share the second laptop? Okay. Okay, so I will start Hexalem here. And I will also start the substrate portal. Okay, so here you can see I'm connected to the chain. And the game should load, okay. So here I have my 2 instances of the game. Oh, they are stacked, okay. Yeah, so maybe let's change the account here. Yeah, I'm on, I will connect to our quick solo node for the demo. And if I enter, I can create a game here. So I will invite Alice. Now I will create a game. We need to wait a bit to initialize it. Yeah, but now as you can see, Alice can already join the game. And very shortly, she will be able to play. Yeah, now we also need to wait for Bob to join. Okay. Yeah, and now we can very easily play this game just by choosing, for example, one tile, and we can place it, for example, here. Yeah. So now we will wait for the transaction to finish. What we can also do is we can also implement a custom animation for it between each transaction so that the players feel like the better flow of the game. And also the selection is shared between the players, but their boards are separate. And now I can end turn for Bob, and now Alice will play very shortly. Yeah, so now it's Alice's turn, and yeah, maybe I can try to place another tile, maybe here. And this is how the game works. Okay, so again, as I mentioned, I strongly encourage you to try the Polkadot Global Series Hackathon, try to build some amazing on-chain games using Polkadot Unity SDK, and hopefully you will win. I will be there to help you, and I want to see some amazing projects. Okay, thank you.